In this lecture, we are going to discuss linear data structure. First of all, we must be clear about what a data structure is. Data structure is the structuring or logical organization or arrangement of particular data in memory. If elements in a data structure are arranged in sequential order, this type of data structure is called linear data structure. Stacks, stacks, queues, and lists are categorized as linear data structures. All of the data needs to be stored in some kind of container or a place in memory. But before storing data practically into the computer memory using a specific data structure, we must understand how we view data or information. A user views his data according to his or her need at application level. At logical level, data is viewed from the perspective of properties and operations that can be performed on data. And at implementation level, we use data structures. But before looking at the different views of the data, we can specify the properties of some data types or containers without worrying about how they will be implemented in computer. Such data types are called abstract data types. In abstract data types, we know what properties they have, that is, what operations can be performed on data, but we don't have any information about the internal structure or how it would be implemented in computer memory. Abstract data types and data structures are two phrases that are sometimes used interchangeably. But remember that data structure is the implementation view of abstract data type. Since we are going to discuss linear data structure, I am going to repeat here the definition of linear abstract data type and nonlinear abstract data type. In linear abstract data types, elements are next to one another in sequence. Examples of such data types are stacks, queues, and lists. And in nonlinear abstract data types, complex hierarchical or more than one relationship exists between elements. Examples of nonlinear abstract data types are trees and graphs. A stack is an abstract structure in which items can be accessed at only one end, called top. If items can be accessed at one end, that means insertion and deletion takes place at only one end. Last item inserted will be the first item removed from the stack. That's why it's also known as last in first out or LIFO structure. Operation of adding an item into the stack is called push, and removing an item from the stack is called pop. And if you try to remove an item from an empty stack, it is called underflow. And adding an item into the full stack is called overflow. Examples of a stack are pile of dinner plates and a stack of books. Here are some of the operations that are related to the fundamental property of a stack, and that is element can be added only at one end, called the top. For adding an element, operation is push, and removing an element, operation is pop. To get topmost element, operation is top or peak, and we can use methods like is full and is empty to learn whether a stack is full or empty. This is simple algorithm to read a value from given data and push it on the stack, and if a stack is not empty, remove topmost or the top element from the stack. A queue is same type of data structure as a stack, but items are inserted at one end called rear and removed at the other end called front. So the element that is added first will be the first to be removed. Hence, this structure is also called first in, first out. Items removed is the item that has been the longest in the queue. Operation to insert an element is termed as InQ, and operation to delete an item is termed as DQ or DEC. These operation names are different in different books, so you can refer to them by their general names as insert and delete. Real-life example of queue is waiting line, where first arrivals will be served first. operations that we can perform on queue, or inserting element at rear and deleting element at front. We can also get length of the queue and learn whether a queue is empty or full. And this is an algorithm with very abstract steps to read and insert data into the rear of the queue and delete the data at the front of the queue until it is not empty. A list is more flexible than a stack and queue from the operation perspective. You can insert and delete elements at any place in list. You can search a list for an element and get the size of the list and perform many other operations like reset, get next, and add more items in the list. A list may have homogeneous items or the items of the same type, and the items are added sequentially. Items are added into the list sequentially, and list length can vary. As well. A list can be ordered and unordered, and there exists semantic relationship between each element of the list. A linked list is the collection of nodes where each node contains two fields. First field contains data, whereas second field contains pointer or information where the next node can be found. Often information of first node of list is given by pointer start, and last node pointer points to null value to indicate that list has ended or it is the last element in the list. Thanks for watching this video. In next video, we will learn about non-linear abstract data types or non-linear data structures.